If you're ready to see the world through the eyes of science and unlock your full potential, you're exactly where you need to be. So go ahead, hit that like button, subscribe to join our growing community, and share this with your friends who could use a little physics magic in their lives. In physics, we deal with physical quantities like speed, distance, force, and time. But not all of them behave the same way. Some just need a number and unit, while others also need a direction. This gives us two types of physical quantities: scalar quantities and vector quantities. Scalar quantities have only magnitude, they tell us how much of something there is. Vector quantities have both magnitude and direction, they tell us how much and in which direction. Examples of scalars include distance, speed, time, mass, and temperature. Examples of vectors include displacement, velocity, acceleration, force, and momentum. Scalars don't depend on direction. Whether you're going north or south, your mass stays the same. Vectors, however, change if direction changes, like going forward versus backward. Scalars are shown with just a number and a unit, like 50 kilograms or 10 seconds. Vectors are shown using arrows, their length shows the amount, and the arrow's direction shows the direction. Adding scalars is easy, just add them like regular numbers. But with vectors, direction matters, you use the head-to-tail or parallelogram method. Now let's talk about adding vectors. We can't just add their magnitudes. Because direction matters, we use the head-to-tail method. Draw the first vector as an arrow. Then draw the second vector starting from the head of the first. The resultant vector is the arrow from the tail of the first vector to the head of the last vector. This final arrow shows the combined effect of the two vectors, in both magnitude and direction. For example, if one force of 5n acts to the right, and another 3n also to the right, the resultant is 8n to the right. But if the second force is in the opposite direction, the resultant is only 2n, and direction depends on which force is bigger. This is why we use arrows and diagrams when adding vectors, it helps us see the full picture. And hey, curious minds, we've got something exciting in the pipeline. If you've ever wanted chemistry lessons alongside physics, you're in luck. We're preparing a full chemistry series, but here's the twist. It'll only launch once we hit 250 subscribers. So if you want to unlock that next level of learning, make sure to subscribe, spread the word, and help us reach that goal. Also, let us know in the comments what physics topics you'd love to see next. Your ideas shape our content. Let's grow, learn, and explore science together, right here at Z Academy.